Good morning on this super misty and foggy Sunday. We don't have a lot that we need to look at today, but what we are going to look at is very new. We've represented proportional relationships using tables quite a bit, using equations where we can represent some of our quantities with variables, and we've looked for things like the constant of proportionality and unit rates. And today we're going to see how you can use a graph to start noticing some broader patterns about proportional relationships. Let us begin with the practice check. This was very closely related to one of the homework problems, which asked about my husband Alan and his sister Nadia, who turned out to be 10 years apart. And in this case, we have two folks who are what looks to be 3 years apart, because when Lynn is 5, her brother is 2. And that means that the next year, when Lynn is a year older and is 6, her brother will also be a year older and will be 3. So we really need to be thinking about how far apart in age they are, because that's never going to change. If you're 2 years apart at one point, or in this case 3 years apart at one point, you will continue to be 3 years apart throughout your entire life. This means that when Lynn is 15, her brother would be 12. And when her brother is 25, Lynn would be 3 years older, so she would be 28. Looking at these quantities, I notice that 6 to 3 is the simplest thing to find a constant of proportionality for, or excuse me, to find a unit rate for. And I notice that 6 divided by 3 is 2. So we would have a unit rate of 2 if we were going from 3 to 6, or a unit rate of 1/2 going from 6 to 3. And that unit rate does not work for any of the other ages. 5 divided by 2 is not 2. The unit rate in that case would be 2.5 going from 2 to 5. And the unit rates are even different when you get down to Lynn being 15 or 28. So even though they are a constant number of years apart, that is an additive thing, like plus 3, and that is not proportional. Now we come over to something that looks more like a classic relationship that we've been paying attention to this unit. We have a very kind of simple situation. We have some t-shirts and they each cost $8. So in this data table that we've filled out already for you, x, if we're going up just 1, 2, 3, 4, 5, 6, and 1 of x is 8 of y, that looks like x would just be the number of t-shirts. Y then represents the cost of those t-shirts, and it's not the cost of each t-shirt, and I wouldn't want you to say just the cost either. We would want to think about the total cost of however many t-shirts you're getting, because one shirt costs $8, but if you go down to 2 shirts, that's total going to cost $16, so on and so forth. Looking at this, we notice that if you have your number of t-shirts and you multiply by 8, you're going to get the cost, and that means we have a constant of proportionality of 8 between x and y. That constant of proportionality you can see in 2 places. You can see that in the situation, $8 for each t-shirt, each one t-shirt, and in the table, one t-shirt costs $8. That's that unit rate, and that holds throughout. Then I asked you to graph this. People seem pretty familiar with the XY relationship. I didn't see people switching up the X and Y. Good thing to remember is that the X is that horizontal axis, and I like to label my axes. We knew that X is the number of t-shirts, and Y is my vertical axis, and that's going to be our total cost. When I graph them, and noticing too that 0 to 10 on the y-axis, we're going up by 2 at each line. So 1 is going to be at 8, so on and so forth. I notice a few things here. I notice that it appears to be going in a straight line. And if I extend that straight line back, it looks like it's starting at the origin, which is 0, 0. So if I buy 0 t-shirts, it's going to cost no money, $0. So things that I notice, we've got a straight line, it's diagonal, and it's starting at the origin. Now the question is, do I keep this line? Should I, fill it in and say that anything on that line would work for this relationship? Well, anything on that line would be x times 8 gives us y. For example, this point here, if we had 1.5 t-shirts, that would get us $10. But 1.5 t-shirts doesn't make sense. In every class, people said that would only work if you're making a crop top. But in general, you're not going to have part of a t-shirt. It's a discrete quantity where you can have 1, 2, etc., some whole number of shirts. So you would not actually fill this line in. You would keep them as the discrete points on the whole numbers. But it is something to notice that it looks like it's making a straight diagonal line that starts at the origin. As you're looking at your homework, for any of the graphs that you have, if you're not sure if it's proportional, a good thing to do is always to make yourself a data table. Put some of those points from the from the graph into the data table, and then check for yourself, does that make a proportional relationship? That way you can see the relation between the graphs that we're starting to work with and the tables that you've been working with already. Have a great weekend.